Spencer, lights please.
Okay.
If I can have everybody's attention. Guys, thank you so much. I hope you had a great break. We have 6 weeks until our next vacation. And
But it's not going to be a full vacation.
actually, it's a full vacation.
Yeah, but they cut it a day short.
They did not.
because of the snow day.
They did
No,
not.
that's for Memorial Day weekend.
That's
Oh,
right.
okay. I don't
Now,
know what the difference is.
guys, you're having a very difficult time concentrating here. I think it's very important that you understand just how important the next 6 weeks are. The next 6 weeks are really critical. We are going to have a lot to cover over the next 6 weeks. And then at the end of those 6 weeks, we come back, and we've got about, give or take, a week and a half to, well, let's call it 2 weeks, 2.5 weeks of work. But within that, you have your 8th grade trip, so you're gonna miss a couple of days for your 8th grade trip. And then you come, it's like the first couple of days of May 5th at the latest, and we're into review for the Regents exam. So these next 6 weeks represent the bulk of what we have to know for the rest of the year. It also represents or contains the harder stuff for the rest of the year, but it's not as hard as some of the stuff we've done. When we get back from the April break, everything is easy. So if you're able to master the work that we're doing now, you really set yourself up for doing a solid job on the Regents exam. To do a great job is gonna require more, and we'll talk about that when the time hits, but you're at least putting yourself in the position where I would say if you do a great job through this week, plus what you've done before this, you're probably looking at a grade at least in the upper 70s.
Okay.
That would be for the kids who have struggled the most, possibly much higher. And then when we get back, we can start identifying the things each individual needs to know to get better at in order to bring up each individual grade. So here's an example. Today's quiz. These are all old Regents exams, or old Regents exam questions. And they're not very difficult, but combine the fact that we just got off of a 1-week vacation, plus the fact that even before then, it's been a little while since we did some of these types of questions, and you were a little off your game. But I think once we go through how to get these right, I think that you'll find that they're pretty easy. So, without any further ado, one thing that I have to do is I have to, I don't have a copy of the quiz. What are we doing here? All right, I don't have a copy of the quiz, so I'm going to need to write these on the board. So I can grab one of these. I cannot, sorry, just project the image. So the first one says solve by completing the square. And how many people got the first one right? If you put your hands up, please. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The bottom line is probably 80% of you got this right. And completing the square is generally thought of as one of the more difficult questions on the test. So it's not the hardest, but it's one of the most difficult. So if you got this right, that's really showing a lot of good things for you. If you didn't get it right, you really need to say to yourself, okay, 80% of the kids in the class just got it right. I can do this, but I have to dedicate myself to getting it done. If that takes a little time and extra help, if it takes whatever, you need to find a way to get it done. So the first thing is that we're completing the square here. And when we complete the square, what are the key words that pop into our mind?
Half and square.
Half and square. So it's half of whatever's in front of the x. So that becomes x plus 5 squared. But in order for this to be a true statement, I did the half. What did I not do yet? The square. So I really needed to add 25 to both sides. Okay? Now, be nice, Chloe. See, you know, when we were growing up, if you cursed, my dad said, watch your French. So you go to Paris, you come back, and you drop the D word, right? Well, look at, see, my dad was on top of that. Now, 8 and 25 is 33. Now, I square root both sides, and I get x plus 5 equals plus or minus the square root of 33. And then I subtract 5 from both sides. X is. Now, I did see a number of people put the plus or minus square root of 33 first, which, as long as you include that plus or minus, is fine. But you will not, I don't believe, see that as a choice on your Regents exam. It will look like this, 98% sure. So make sure you understand that that radical typically is put at the end. Because of the commutative property, you're not wrong, but typically this is how it is, okay? Any questions? All right, now, let's go to the next one. It says the parabola. Oh, gotta get the old man reading glasses on here. Y equals 3x minus 4 squared plus 7. Now, does anybody remember what the name is for this type of writing a parabola, what form this is? It actually says it in the question. Vertex form, very good. So it is the vertex form, and the reason we call it the vertex form is that just by a quick cursory look at it, you can see what the vertex is. In this case, the vertex is always what we call HK, and in general, this is the vertex form. So that means that H is this number here, and K is this number here, so the vertex is 4, 7, done. All right, again, most people got that one right too. That was one of the types of things that we were working on in the week or so leading up to the break. All right, any questions? All right, now we go to number 3. And number 3 says the following. I really wish, I think sometimes, here's a general truth for life that this will really help you if you're able to do this. Anyone who allows themselves to think first and foremost about their circumstances is inhibiting their success. And what I mean by that is, a couple of examples. If I'm with the wrestling team and I'm running at the end of practice and I say to the team, we're gonna do 50 push-ups at the end of practice, every single kid will tire at 42. If I tell them we're gonna do 20 push-ups, every kid will tire at 18. Because they're thinking, oh my God, I still gotta go, I got 7 more to go. Rather than just do it. Another example would be something like, you get a teacher who gives you an unfair test. And you think about how unfair that test is. But when you're thinking about how unfair that test is, you're not thinking about how to do the questions to the best of your ability. So not only is the test possibly unfair, but now you're not getting the best out of yourself. So you got a double whammy that's hurting your score. Another example, everybody here play baseball? No one in this room plays baseball or softball, no one.
My sister does.
All right, well, here's the deal. If you ever go out there and you look at the umpire and you hate his strike zone, and you're like, that's not a strike. And all you can think about is the past pitch where the ump called a strike on something that you swear wasn't a strike. You're not gonna hit the next pitch that comes in. Because you're still thinking about the previous pitch and how frustrated you are about that. Well, I think that kids see this particular question and they start thinking of how frustrated they are at the question. But I think if you stop thinking about how frustrated you are and just read the question, it's easy. It's very similar to completing the square question. Lila completes the square for x squared minus 12x, x squared minus 12x plus 7. In order to find the minimum, she has to put it in this form. Now, it says, what's the value of A? Do I care about B?
No.
Now, the B part can be a little confusing. I'm with you on that. But I only care about A. What are the 3 words that we use? Half and square. What's the half, guys?
Negative.
So it becomes x minus 6 squared. So what's the value of A?
Negative.
No.
Positive.
A is 6, yeah. Because it's supposed to be x minus h, see? So
Oh, so
the
it's
x and the
not-
minus, are the same, so the A is just the 6.
So you negate it.
It's always opposites in a parenthesis.
Okay.
All right. So that's it, you're done.
Is that a 9?
No, that's an A,
Oh.
and that's a 6.
I was
yeah.
like, why is
Okay.
that a 9?
Now, the very last question. How many roots does this have? There are 2 ways to consider roots. The first way to consider roots is graphing. Take your graphing calculator, put the equation in, and graph it. Go ahead, do that. How do I find the roots according to a graph? Who's gonna help me on that? How do you find the roots with a graph? Go ahead.
You gotta find where it connects, the.
All right, let me rephrase the question. How can you tell how many roots by looking at a graph?
What it is the power.
No.
No.
No, you're the only one in the room who thought that. Go ahead.
Yeah.
If it crosses, if it touches the x-axis.
That's right.
Maybe
How many times does it touch the x-axis?
one.
Look at the graph. It doesn't touch the x-axis.
Yeah.
Therefore, there are no roots. No real roots.
So,
Okay? Right? Perfectly said, Sydney. Sydney, in the most whiny voice imaginable, said, "Oh my God, it's so
I just thought it
easy."
was 2 because it was a problem. I was like, oh my
Yep,
god.
that's what.
Now, the other way is by looking at the discriminant. B squared minus 4AC. And in this equation, what is the value of B?
-2.
So if I square that, I'm gonna get -2 squared is 4, minus 4 times 1, and I think C is 5.
Yep.
So that becomes 4 minus 20, which is -16. Which means under the radical part of the quadratic formula, you would have the square root of -16. What's the problem with that?
That's an imaginary number.
It's an imaginary number. If it's an imaginary number, there are no real roots. Therefore, there are no real roots. So you can look at it by using the discriminant, or you can graph it and see how many times it touches the x-axis. Yes?
So on a test, what do you make a show work for this, or can we just,
It said justify your answer.
so then?
And the way you can justify it is either by showing the work with b squared minus 4ac using the discriminant, or saying I graphed it on my calculator and it doesn't touch the x-axis. Either one is good to go. Yes?
Now, couldn't we just like solve this, find the roots, and then realize that there's no way to solve it?
Yes, you could. That's the longest, most difficult way, but you could do it that way. All right, so that is your quiz. I think in retrospect, it wasn't particularly difficult. All right, so the next one, solve for n. The first thing I want to do is factor out a 2. And we have talked before about how you could divide everything by 2, but I consider that very dangerous, because if the direction said to factor instead of to solve, everybody would get it wrong. So I go here, and then I get maybe, it's the guy in the middle, or the left, the right, the middle, so 2 could equal 0, n plus 7 could equal 0, n minus 3 equals 0. Now 2 equals 0 is ridiculous, that's done. Minus 7, n is -7, plus 3, n is 3. So the two solutions are n equals -7 and n is equal to 3. Okay? Any questions? All right, next one just asks you to, on your graphing calculator, graph y equals 2x cubed, which is going to look something like this, and y equals the square root of x minus 4, which will look something like that. Okay? I just wanted you to remind yourselves of how to do this on a calculator, okay? Does anybody remember what this -4 at the end does to the graph? Go ahead.
Lowers it.
Yeah, it's vertical shift. It lowers it 4 units. Does anybody remember what the 2 does in front of the x cubed?
It makes it wider.
Actually, no. Sometimes it could be wider, sometimes it could be skinnier. In a cubic graph, it actually makes it
Right.
skinnier or more narrow. No. What it does is it makes every y value twice as big as it would have been, which means it kind of gets taller faster. Now, if I had a square root curve and I put a 2 in front, it would get higher faster. So it basically increases the height, because the y becomes twice as big. All right, are there any questions? All right, so let's talk about what our lesson is for today. And our lesson today is going to take something and make it pretty simple. All right, by looking at this, what do you notice about the similarities of the graphs and so on? Y equals x, or f of x is x, g of x is x plus 5, and h of x is x minus 6. What do you see going on here? Come on, Anthony?
They're all x's.
They all have x's, and then on the last two, something is being done to the x's. What's being done here? Everybody?
Addition.
Yeah, and it's what kind of shift, vertical or horizontal?
Vertical.
Vertical shift. You're shifting it up 5. What are you doing here?
Shifting it down.
Down 6. This is called the parent function. It's the most general form of the function with nothing being done to it. And then we have vertical and horizontal shift that we could do. What about the next one? What's the parent function? Everybody.
X squared.
F of x is x squared. What is the plus 3? What does that do? What's the effect there? Everybody? Vertical shift, it moves it what? Up 3. And then this one? Down 7. Good. All right, this is the absolute value function. Now, the 3 and the 4 are in the grouping symbol, whether that grouping symbol is a parenthesis or an absolute value symbol. And that means that it's not vertical shift. What is it? Horizontal shift. So this one, g of x, will shift it how?
Plus 3.
To the left 3 is correct. Don't pack up. It's reversed. What about this one? To the right 4. Good. So now, how do we put it all together? We actually transfer the, hey, stop and focus. We actually transfer this graph. Do you see how this is going to be y equals x squared? And this is moved 1, 2, 3, 4 to the right? So this would be y equals x plus 4, pardon me, x minus 4 squared. What would this one be? Y equals, first off, is there any horizontal shift? Yes, I'm moving where? 2 to the left. This is an absolute value graph, so it's going to be y equals absolute. Remember, you're reversing the grouping symbol, x plus 2. And then what's the horizontal shift?
Minus 3.
Minus 3. So now I can just look at the graph, investigate vertical and horizontal shift, and apply them. One last one. All right, this is the square root curve. It goes up 1, 2, 3, 4, 5. So it's y equals square root of x plus 5. We will do one more day of this tomorrow. Hasta la vista. Vaya con Dios. Toodaloo. Ka-ka. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Garushurus. Kadafis.